Welcome to a pivotal moment in artificial intelligence history. Between 2025 and 2026, we witnessed a total structural overhaul of the large language model. Today, we're doing a deep dive into how and why the dense transformer era came to an end. For nearly 7 years, the dense transformer was king. But as we pushed for human-level reasoning and massive context windows, we hit a memory wall. The quadratic cost of attention meant we needed a smarter way to scale. Today, we're exploring the post-transformer era, a shift from static prediction to dynamic reasoning. We'll cover 3 pillars: universal MOE, hybrid SSM transformers, and inference time compute scaling. By late 2024, the industry hit a wall. Traditional scaling, simply adding more data and more parameters, was yielding diminishing returns. The cost to train a GPT-5 class model was becoming unsustainable for even the largest tech giants. We were running out of high-quality human data. This forced researchers to look beyond the architecture itself and focus on how models process information during both training and inference. Let's start with the rise of Universal Mixture of Experts, or MOE. It's no longer just an experiment, it's the foundation of every major frontier model in 2026. MOE decouples a model's total parameters from its active compute. You get trillion parameter knowledge with billion parameter speed by only activating the experts needed for a specific prompt. DeepSeek v3 was the first major shock to the system. It proved that a model could achieve frontier-level performance with a fraction of the active parameters, thanks to its revolutionary multi-head latent attention mechanism. They solved the expert balancing problem without using traditional auxiliary losses, which used to hurt model quality. This paved the way for the massive 600+ billion parameter models we see today. A key innovation is the shared expert. It captures general language patterns across every token, while specialized experts handle the heavy lifting for domains like Python coding or complex calculus. This solved the load balancing issues of the past, making training more stable and inference significantly cheaper, which is why your AI assistant is so much faster now. But MOE was just the beginning. The biggest structural shift was moving beyond pure transformers to solve the context crisis. Pure transformers struggle with the KV cache bottleneck. As context grows, memory needs explode quadratically, making long context reasoning prohibitively expensive for most users. Enter state space models, like Mamba. They offer linear scaling, meaning memory use only grows slightly as you add more text, making massive context windows, up to 1 million tokens, finally efficient. To understand why Mamba changed the game, look at the math. Traditional attention compares every token to every other token. Mamba compresses that history into a hidden state that updates linearly. It's the difference between rereading a whole book for every new word and just remembering the plot. This hidden state is the secret sauce. By interleaving these linear layers with traditional attention, we get the best of both worlds: infinite feeling context and surgical precision for fact retrieval. The breakthrough of 2026 is the hybrid architecture. Most flagship models now use a 75-25 ratio of SSMs to transformer layers, striking the perfect balance between efficiency and reasoning power. This hybrid approach reduced memory requirements by nearly 90%. This means you can now run a high-end reasoning model on a laptop that would have struggled with a basic chatbot 2 years ago. We've moved into the era of infinite context. Techniques like ring attention and blockwise transformers, combined with hybrid backbones, allow models to process entire libraries of technical documentation in a single pass. Now, let's talk about the System 2 revolution: inference time compute scaling. This is where AI moves from guessing to thinking. Historically, models just predicted the next token as fast as possible. Now, models like OpenAI's O-series use internal search and verification to check their work before giving you an answer. OpenAI's O1 and O3 models proved that spending more time thinking during the answer phase is often more effective than spending months in pre-training. It's the reasoning scaling law. By 2026, these internal chains of thought are being distilled. We are training smaller models to mimic the reasoning traces of the giants, making high-level logic accessible and fast. We're also finally cracking the black box. Sparse autoencoders, or SAEs, allow us to see exactly which neurons represent honesty, coding logic, or even sarcasm. This is critical for safety and alignment in the 2026 era. Because we can identify these features, we can now steer models with surgical precision. We aren't just training them anymore. We are literally tuning their internal concepts. This shift is powered by NVIDIA's 2026 Vera-Rubin architecture. It attacked the memory wall by integrating HBM4 memory directly into the package, providing the bandwidth these MOE models crave. In 2026, architectures went truly omni. Models like GPT-5 and Gemini-2 process speech, vision, and text as native modalities, allowing for zero-latency, human-like interaction. This native multimodality means the AI isn't just reading your text, it's watching the world through your camera and hearing your tone of voice in real time, all through a single unified architecture. We're also seeing an edge revolution. Thanks to 4-bit and even 1.58-bit quantization, trillion parameter class intelligence is now being squeezed onto high-end smartphones and laptops. Running these hybrid models locally isn't just about speed, it's about privacy. Your most personal data never has to leave your device to be processed by a frontier-level mind. Economically, we've hit a tipping point. The cost of intelligence has dropped so significantly that we are entering the era of commoditized intelligence. Reasoning is now too cheap to meter for most basic applications. Finally, the architecture itself is becoming agentic. We aren't just building chatbots anymore. The 2026 models have planning and tool use layers baked directly into their core, allowing them to act as autonomous engineers. Looking toward 2027, the focus is shifting toward collective intelligence, networks of specialized hybrid MOE models that collaborate to solve global-scale problems in science and energy. The era of the simple, dense transformer is over. We have entered the age of the efficient, reasoning, and multimodal agent. The foundation for the next decade of AI has been laid. Thanks for taking this journey through the 2025-2026 revolution with me. The future of architecture is here. See you in the next one.